Hello dear friends, welcome to the Mr. Professor YouTube channel. In the last lecture, we have discussed the previous year from the NEET and MHT CET. And so in this video number 5, that is our topic, under the topic we are discussing the previous year, that is nothing but the rotational dynamics, and we are discussing only the previous year questions. Now see, in this video lecture, again we are going to discuss the 3 more numericals which are from the previous year questions, and the first one is from NEET 2018 and second one is from the AIPMT 2014. These are the 2 questions from the medical. Okay, NEET is for the medical and the AIPMT was for the medical previously before NEET, and the third one is from the Maharashtra CET 2014. And the concept, okay, on which these all 3, this is the third question, that based on the conservation of energy, and these are the numericals came from the rolling motion concept. Now see the first one. We are going to discussing the solution for the first one. Okay, first of all we will read and carefully write what they have given in that numerical. A solid sphere is in a rolling motion. Okay, you know the solid sphere which is in the rolling motion. In rolling motion, a body possesses translational as well as the rotational kinetic energy. Okay, if I draw a free body diagram, this is the solid sphere. Okay, and performing rolling motion. Okay, rolling motion like this, like this, like this, and like this. Okay, translational. Okay, rotational plus translational. Okay, rolling motion is the rolling. Okay, the concept of rolling motion. In rolling motion, they perform, the body and the object perform the 2 types of motion. First one is the translational. Okay, the body is moving forward, and the second one is the rotational. Therefore, the body have the 2 types of kinetic energy. From rotational motion, body have a kinetic energy regarding the translational, and from the rotational one, body have the kinetic energy with respect to the translational motion. Therefore, the total kinetic energy in case of rolling motion becomes kinetic energy for translational plus kinetic energy for rotational motion. This is the kinetic energy in case of a rolling motion. That is, I can say that the total kinetic energy in case of a rolling motion. Okay, now they are asking to find, okay, this is the given data what we have depict in the free body diagram of a rolling motion of a solid sphere. This is nothing but the solid sphere having a radius r and the mass m. They are asking to find the ratio of k suffix t is nothing but the translational kinetic energy, and the kt plus kr, that is the translational plus rotational kinetic energy, combines the total kinetic energy. It means that they are asking to find the ratio of translational to the total kinetic energy. Okay, first of all, by reading carefully, we have to, okay, we need to show that, okay, what is first of all we have to carefully, after that carefully reading, we have to know what they are asking. Okay, we have to identify, we have to recognize, okay, from the reading what they are asking. Okay, we have recognized, we have identified that they are asking to find the ratio of translational to the total kinetic energy in case of a rolling motion of a solid cylinder. Clear? Okay, so then we should know the formula for the translational kinetic energy and the rotational kinetic energy. Okay, now see, in case of a translational kinetic energy, the formula is half mv square, but in case of rotational, the formula is half I omega square. Now keeping the values for the moment of inertia and omega, okay, we have the relation between v equals to r omega and omega equals to v divided by r. So in place of omega, you can write now omega square becomes v square upon r square. Okay, and value for the general definition of moment of inertia mk square. By keeping these values omega square and I in this equation, you get the value of a rotational kinetic energy. Mk square and omega square is nothing but v square by r square. This is your rotational kinetic energy. This is your translational kinetic energy. Clear? And again we want a total kinetic energy, then add this to one. This is your total kinetic energy. Now you can see that half mv square is the common in case of translational and rotation. Therefore make it common, half mv square. What remains here? 1. What remains here? K square by r square. This is your total kinetic energy. Now just you have to be put the values for the given formula. Okay, that is nothing but the translational, and this is nothing but the total. What is the value for translational? They are asking to find the ratio of a translational to the ratio of a total kinetic energy. What is the formula for translational? Half mv square. What is the formula for total? Half mv square is a common, and the 1 plus k square by r square. Now you can easily see that the half mv square get cancelled. What remains in the numerator? 1, and in the denominator 1 plus k square by r square. Okay, if you now see, okay, to get the final answer you should note the ratio of k square by r square for the solid cylinder. Now see, moment of inertia. Okay, the general formula of moment of inertia is nothing but mk square. So now compare this formula with the moment of inertia of a solid cylinder, that is nothing but 2 by 5 mr square. 2 by 5 mr square. Now see, now from this you can adjust the k square by r square value. Okay, get cancel. Okay, r square on the right hand side, shift it on the left hand side, therefore k square by r square. What remains on the right? 2 by 5. Then what is the value of k square by r square? 2 by 5. Put this value here, you will get the ratio. Therefore 1 plus 2 by 5. Okay, make the base same. Okay, then multiply 5. Okay, below and above. Therefore 1 upon 5 plus 2, 7. 7 divided by 5. Therefore 5 by 7. Therefore 5 is to 7. This is the ratio for translational to the total. 5 is to 7. Therefore the option number 2 will be the correct option for the given numerical. Okay, just a simple. Okay, if the body is performing rolling motion, okay, the body is in, if the body is in motion, and then you should know, and we will know the, if any object which is in the motion, okay, containing the kinetic energy, that body have a kinetic energy. But if the body is performing the rolling motion, then there are the two types of motion body is performing. The first one is translational and the second one is rotational. Then the kinetic energy corresponding to the translational, then the kinetic energy corresponding to the rotational. If we combine these two kinetic energy, you will get the value of total kinetic energy for the rolling motion, and they are asking to find the translational to the total. So we have made the formula for translational, okay, and for the rotational, and combining these two formulas of kinetic energy, we get the formula for the total kinetic energy. Okay, then keeping these formulas to this given biodata formula, then half mv square get cancelled. What remains? K square by r square. And using the moment of inertia definition, okay, we have to use the general definition of moment of inertia, and that definition we have to compare with the moment of inertia of a given object to get the value of k square by r square. Okay, you can see that easily we got the value for the k square by r square, that is 2 by 5. Then putting this value, we got the ratio 5:7 for this given example. Okay, so note down. Okay, note down. I will remove it. Okay, now we will move to the second another numerical, which one is from the AIPMT 2014. Before NEET exam, NEET is the All India entrance test for the medical. Before NEET there was a AIPMT exam, which is also for the all India level, okay, not only for the state level. Now we are discussing the question number 2. The concept is same, okay, as we have discussed in the early example. Okay, now see the ratio of acceleration for a solid sphere. Okay, again in the two example, okay, if we compare the two example, the solid sphere object is similar in both case. Okay, the ratio of the acceleration of a solid sphere whose mass is m and having a radius r, rolling down an incline of an angle theta. Okay, if we plot the inclination of an angle theta, here is a solid sphere and rolling down from that platform. Okay, this is radius r and having a mass, and this is the center. Okay. Okay, now see what they are asking. Rolling down at an angle theta without slipping and slipping down, incline without rolling. Okay. Now see, they are asking to find the ratio of accelerations. The ratio of accelerations. There are two types of acceleration. If body is rolling down, if the body is rolling down, then at that time the body having acceleration of rolling. Body having the acceleration of rolling. If body is not rolling, body is skidding, body is sleeping, then there is acceleration of sleeping. Okay, okay, are you noticing what I am saying? There are the two types of acceleration will be there, because depending on the motion. If the body is rolling down, it means that body is moving forward, but okay, but about its center. Okay, it is also rolling, it is also rotational. Okay, body have the two types of motion, translational plus rotational. Then the acceleration becomes the rolling acceleration. But without rotational motion, if body is just doing a skidding with the, that is nothing but the body is just doing the translational motion, then the acceleration becomes the slipping acceleration. And they are asking to find, see, the ratio of the acceleration in between, okay, without the acceleration of without slipping. Without slipping means the acceleration of rolling. Okay, and slipping down, incline without rolling. Without rolling means the body is sleeping. It means that they are asking to find the ratio of the acceleration of rolling to the acceleration of sleeping. Okay, first of all, we have to recognize, we have to identify from the given data what they are asking, and we have identified that they are asking to find the ratio of a rolling acceleration to the sleeping acceleration. Okay, now see, in that case, okay, in this case you should know the formula for the velocity and acceleration. Okay, this is the formula for velocity 2gh upon 1 plus k square by r square, and this factor 1 plus k square by r square, okay, is due to rolling motion of that object. Okay, this factor, if there is no rolling motion, then the formula becomes v equals to square root of 2gh. Okay, then this is the negligible 1 plus k square by r square, 1 plus k square by r square. Okay, this is this velocity formula is for the rolling, and this velocity is formula when the body is sleeping. Okay, now see, similarly we have the two types of accelerations. If the body is rolling, then we have the acceleration g sine theta upon 1 plus k square by r square. Okay, if body is sleeping, then neglect this factor, then what remains? G sine theta. These are the two formulas for the rolling and sleeping. Okay, are you understanding what I am saying? This factor 1 plus k square by r square. Okay, this factor 1 plus k square by r square, you can notice, okay, you can see in this formula when when the body performing a rolling motion, but when body is sleeping, then that factor can be neglect. Okay, why we have neglect is there? The body is sleeping. Why we neglect here? The body is sleeping. If body performing pure rolling motion, then the factor will be there. Okay, the factor will be negligible when body performing sleeping, body is skidding on that inclined surface. Clear? Now see, these are the two formulas we have to put here. What is the ruling? That is nothing but g sin theta upon 1 plus k square by r square. And what is the for sleeping? G sin theta. So therefore g sin theta get cancel. What remains then? 1 upon 1 plus k square by r square. Therefore 1 upon 1 plus. Okay, we shall note the ratio of k square by r square for solid sphere. This is the case of a solid sphere. And in case of a solid sphere, okay, recently in the last example we have found that k square by r square for solid sphere is nothing but the 2 by 5. Therefore put the value of k square by r square, that is nothing but the 2 by 5. Now see, okay, make the base same, multiplying 5, therefore 5 by 7. Therefore 5 by 7. Okay, or I can write 5 is to 7, or I can write 5 is to 7. Okay, this is the second one we have solved it. Okay, so carefully note down. We will move to the third one. Now see the last question, which is based on the conservation of energy. Okay, you should know if the body is, there are the two states of any object. That is the state of motion, and the second one is the state of rest. If body is performing motion, then the body is in a state of motion. Then at that time body having a kinetic energy. If the body in the state of rest, then the body having a potential energy. Okay. The question is from Maharashtra CET 2014. An object of a radius r. Okay, we don't know object, but they are saying that object having a radius r, then that object will be the circular one having radius r, and the mass m is rolling horizontally without slipping. Okay, without slipping means rolling. Okay, this body is rolling horizontally without slipping. Body is not skidding. Body performing two motions, translational as well as rotational. That is nothing but the body is rolling down without slipping with a speed of, that body having a speed of v, if then rolls up the hill to a maximum height h. Okay, the body, okay, goes to the height h. Okay, and they have given the height, that is nothing but 3v square upon 4g. Clear? The moment of inertia of the object, it means that they are asking the moment of inertia. Okay, it means that they are finally asking which body is this. Okay, is this solid cylinder, is this disc, is this ring? Okay, if you get the value of moment of inertia, then you can easily find out, because you already know the moment of inertia of some objects, mr square ring, mr square by 2 disc, mr square by 2 solid cylinder, like this. Clear? Now see, okay, now see, here is a, we can use the conservation of energy, okay, before and after. Okay, now see, if the body is reaching to some height, then the body finally and after, body is at a rest, and before body is going to that state, body is in the motion, and in motion there is energy, kinetic energy, and in rest there is any energy, potential energy. So but the, in this given, the body is rolling, therefore there are the two types of kinetic energy, translational plus rotational. Okay, and what is the formula for potential energy? That is nothing but mg and h. Okay, You should know the formula for kinetic translational, half mv square, and rotational half mv square k square by r square equals to mg, and they have given the value of h, that is nothing but 3v square upon 4 into g. Okay, from this we have to find out the moment of inertia. Now see, okay, and as we know that the basic formula and the general formula for moment of inertia mk square. Okay, in case of mk square I can write moment of inertia I, therefore half mv square plus half mk square v square by r square equals to, now see, small g get cancel, therefore 3v square upon m divided by 4, small g get cancel, what remains above m 3v square and in the denominator g, numerator, now see half mv square, here half mk square is nothing but the moment of inertia and the v square by r square, therefore 3v square m divided by 4. Okay, now see, I am removing these two examples which we have already done. Now see, we have, our aim is to calculate the moment of inertia. Okay, that's why I am shifting these terms on the right hand side. On the left hand side what we have, 1 by 2 I v square upon r square, on the right hand side 3 v square m divided by 4, and I am going to shift these terms on the right hand side, therefore plus becomes minus 1 by 2 mv square. You can clearly see mv square is the common. Okay, what remains, 3 by 4 minus 1 by 2, just to make it the cross multiplication. Okay, 6 minus 4 divided by 8. Okay, therefore 1 by 2 I v square upon r square. Now see, therefore 1 by 2 I v square upon r square equals to m v square. Okay, 6 minus 4 2 divided by 8, it means that 1 by 4. Now see, v square get cancel, shifting r square there, therefore I. Okay, now I am going to shift. Now see, v square get cancel, shifting r square, therefore m r square divided by, okay, shifting also 2 divided by 4, therefore 2 ones are 1, 2s are 2, therefore m r square by 2. This is the moment of inertia for disk or solid cylinder. Therefore the object may be mr square by 2, therefore object may be disk or may be solid cylinder. Okay, in this way they can ask anything. Okay, you already see the level of questions, how they are asking. Okay, this is the question, the third question is from the Maharashtra CET, but the level is matching with the NEET exam, with the JEE exam. Okay, so thank you for watching. See you in the next video.